Introduction. Soil moisture sensor, as the name suggests, can detect amount of moisture in soil, root of a plant. It is low-tech sensor. This sensor is compatible with Arduino Mega 2560, Arduino ADK ECT. Objectives of soil moisture monitor sensor. Optimize irrigation. By monitoring soil moisture levels, farmers and gardeners can determine the optimal time and amount of water required for irrigation. Improve crop yield. Maintaining optimal soil moisture levels is crucial for plant growth and productivity. Water conservation. Efficient water management is essential for sustainable agriculture and environmental conservation. Prevent plant stress. Soil moisture monitoring helps identify periods of low moisture content in the soil. Disease and pest management. Certain plant diseases and pests thrive in specific soil moisture conditions. Research and analysis. Soil moisture data collected over time can provide valuable insights for research and analysis purposes. Components for soil moisture sensor. List the components required for the project, including soil moisture sensor, Arduino board, water pump, power supply, connecting wires. Working principle of soil moisture sensor. Resistive sensing. Resistive soil moisture sensors consist of two or more metallic electrodes embedded in the soil. The moisture content in the soil affects the electrical conductivity between the electrodes. When the soil is dry, it has high resistance, resulting in a higher voltage drop across the electrodes. As the soil becomes more moist, the resistance decreases, causing a lower voltage drop. By measuring the voltage drop or resistance between the electrodes, the soil moisture level can be determined. Capacitive sensing. These sensors typically consist of two electrodes, one acting as a probe and the other acting as a ground reference. The moisture content in the soil affects the dielectric constant and thus the capacitance between the electrodes. When the soil is dry, it has a lower dielectric constant, resulting in a lower capacitance. As the soil becomes more moist, the dielectric constant increases, leading to a higher capacitance. By measuring the capacitance between the electrodes, the soil moisture level can be determined. Time domain reflectometry, TDR. TDR soil moisture sensors use pulses of electromagnetic waves to measure soil moisture. The sensor sends a high-frequency electromagnetic pulse into the soil. The pulse travels through the soil and gets reflected back when it encounters a change in dielectric properties caused by soil moisture. The time it takes for the pulse to travel and return is measured. Moist soil causes a slower pulse travel time compared to dry soil. By analyzing the pulse travel time, the soil moisture level can be calculated. Arduino program for soil moisture sensor. How the soil moisture monitor sensor works. The soil moisture monitor sensor consists of two main components: a probe and a transmitter. The probe is inserted into the soil at a specific depth and measures the electrical conductivity of the soil. This information is then transmitted wirelessly to the transmitter, which sends the data to a central database. The sensor can be configured to take readings at specific intervals, allowing farmers to track changes in soil moisture levels over time. The data can also be analyzed to identify trends and patterns, providing valuable insights into crop management practices. Applications of soil moisture monitoring. Soil moisture monitoring has a wide range of applications beyond traditional agriculture. It can be used in landscaping and turf management to optimize watering schedules and ensure healthy lawns and gardens. It can also be used in environmental monitoring to track changes in soil moisture levels in natural ecosystems. In addition to these applications, soil moisture monitoring is also used in research settings to study the effects of climate change on soil moisture levels and plant growth. By providing accurate data on soil moisture levels, researchers can better understand the impacts of climate change on the environment and develop strategies to mitigate its effects. Conclusion. The soil moisture monitor sensor is a powerful tool for optimizing agricultural practices and improving crop yields. By providing accurate data on soil moisture levels, farmers can reduce water usage, save money, and improve sustainability. The sensor also has applications in landscaping, environmental monitoring, and research settings. While there are some challenges and limitations to consider, the benefits of soil moisture monitoring far outweigh the drawbacks. As technology continues to advance, it's likely that we'll see even more sophisticated and accurate sensors in the future, further improving our ability to manage soil moisture levels and ensure healthy crops and ecosystems.